with this expression that you're seeing right here, it's actually not in simplest form. We're actually able to kind of multiply this out and get it into a polynomial where there are separate terms, and this would be then in simplified form. So we need to make sure we understand exactly what an exponent means, and that will then determine how we should actually go about determining the result of this. So it does turn out that in order to take the quantity of n minus 7 that's in parentheses and then square it, we know that an exponent tells you the number of times you repeatedly multiply something with itself. So the only way to get the correct simplified form answer for this is to write out the exponent number of times that base and then multiply. So I want to multiply n minus 7 with n minus 7, and if I want to multiply the n minus 7 quantity with itself, then I should put parentheses around that, and then of course there's going to be some FOIL involved with this. So you're going to end up getting then n squared, you're going to get a negative 7n and another negative 7n, which will combine to give you negative 14n, and then a negative 7 times a negative 7 will give you a 49. So it does turn out that this right here is the correct answer to be able to simplify that expression. So a common misunderstanding that may happen from time to time is thinking that, oh, can I just like do that, right? Like, can I just distribute the 2 to both things and make it then n squared plus 49 or something like that? And the answer to that is no, we can't, because that's not what an exponent does. An exponent doesn't multiply. An exponent tells you how many times you're supposed to multiply something with itself. To bring even more insight into that, so like I really don't like that I did that, because you should never do that, okay? So just like erasing that from your mind. The reason why that like doesn't work with like numbers and such is, like, for example, like if you had an addition or subtraction of some things. So let's say if I had 8 plus 3, right? And then I was going to try to square that. So the correct answer here is to do 11 squared. So the correct answer would be 121 to this particular problem, right? So if you thought that you could take this square and like square everything and do 64, and then you could square that and get 9 and then add that together, well, 64 plus 9 equals 73, but that doesn't give you the correct answer of 121. So that shows you why like an exponent doesn't multiply to anything, right? An exponent tells you how many times you're supposed to multiply something with itself. So that's always how you need to go about things whenever you're squaring or when you're cubing or raising something to the 4th power, whatever it might be. Literally write that out that many times and then approach the multiplication in that particular regard. So you're going to actually see that the result that we got right there is going to be kind of a particular form that we can just kind of generalize. And when I say generalize, whenever you have something plus something else in your squaring, we know that to multiply this out, of course, that you have to write this out as a plus b times a plus b 2 times, because it's squared, and then you have to FOIL all of that, right? Which means that you're going to get a squared, and then a times b, but then b times a are like terms, so you actually end up getting plus 2 times ab, and then finally plus b times b, which is going to be plus b squared out of that. If you do FOIL out this other one right here, basically the only difference you're going to get is that just the middle term is subtracted. Otherwise, everything else will be positive when you FOIL things out right there. So just kind of exemplifying how that ultimately works out is like when you think about this n minus 7 squared sort of example, there we go, n minus 7 quantity squared. So if you treat this right here kind of as your a, just like I have right here, and then you treat this right here as your b, kind of like I have right here, the answer to this is supposed to be your a squared minus 2 times your a times your b plus your b squared, based on what we're seeing here, right? So if you do plug in the n, because since that's your a, and then you plug in the n, and then also the 7 right there, and then you plug in the 7 right there again, then when you simplify all of that, what you end up getting as an answer is n squared minus 14n plus 49, which there, of course, that simplified answer is the same answer that we got previously up there. So it just shows you how these identities between a plus b, that quantity squared, how it gives you that, and then similarly here, how those really work and function. Then I also want to make sure that you see right here kind of an area model version of this multiplication, that when you do take something that's a plus b long and then something else that is also a plus b long, then of course it's going to be a square perfectly, not just a rectangle, a square, because the dimensions are the same. And then if you break apart each of those area pieces, you're going to see you're going to have a section of it that's going to be an area of a squared, and then something that's a times b in dimensions, a times b, and then another little square that's b squared in terms of area there. One quick thing that I want to add to all of this right here is that what we were really doing in all these examples here is we were taking some expression and multiplying it with itself, because we were squaring like n minus 7, right, or a plus b, that sort of a thing. And so whenever you do multiply something with itself in math, right, you're squaring something. And so what you're seeing like right here is really the square of something, and we would call it like the square of a binomial. Okay, and that's the same thing that's true right there with an a minus b squared. So when you simplify out the square of a binomial, you're going to end up getting an expression like this a squared plus 2ab plus b squared, or like that expression right there. Or when we did the n minus 7, that quantity squared, we ended up getting something like that, which was the result of squaring a binomial, right? And whenever in math you multiply something with itself, you get what we call a perfect square. So it does turn out that the things that I underlined in red right there, we refer to as perfect squares. So you really want to get used to understanding this structure of an expression as being the structure of what a perfect square, really a trinomial perfect square is. Trinomial because it has 3 terms. That's something that's going to be really important for us as we continue throughout algebra, because we're going to be dealing with lots of special case sorts of things later on that deal with perfect square trinomial.